Alright guys, because my original project did not go too well, what I'm going to be showing off in this video is what I learned from disassembling the drill and the different components I was planning to use from it. And even though it didn't go so well, I still learned a lot, even more than I originally planned. So I'll just start talking about that now. When I first took apart the drill, the first thing I had to do was unscrew a bunch of screws from the body of the drill. You know what a drill looks like. There's just a bunch of screws in the side, and I took those out, and I was left with this part right here. This was still on top of here. I'll show you how I got that off, or tell you how I got that off in a minute. And so this was on here still, and this was connected into the back of this, and the little notches on here went inside here. Um, anyway, so I guess I'll talk about how I took it apart first. I was able to get this off of here, which is the first step, I guess. So you have to loosen this all the way so all these three bit holding prongs are all the way in, and we'll let the screw out. And there's a big screw in here that you can take out with a screwdriver. I used a small Phillips head, or I guess short. It was a big head, but a short screwdriver. Anyway, I unscrewed that, and you can see the threading in here, and then that allowed me to unscrew this whole piece from here. That unscrewing this piece allowed access to this oddly shaped washer and this oddly shaped washer, and I believe there is a C-clip underneath there that I had to take off, and that allowed me to get this whole piece off, which you can see I did right here. Next, there was another smaller C-clip down here, as well as a washer or two that are used to hold on the rest of this. Anyway, after I got that C-clip and washer off, there were some ball bearings in here that you can see some from the other part of this drill I took apart in here, and I just dumped those out. And then that allowed some of this to come loose, and this black piece was able to unscrew, and the spring you can see right here was also able to come off. And that left me with just this, as well as this still inside here, and that was able to come out after the C-clip was removed. Anyway, so what I was left with was this white piece right here, which is the middle part of the drill head, which is it's more of a showy part. It doesn't really have a whole lot of function except for these ball bearings, which help the drill to spin. So after the whole thing was said and done, I was allowed with these pieces. I was left with these pieces, as well as a few smaller C-clips and washers that are off to the side, and a bunch of ball bearings, which were annoyingly messy to pick up after I spilled them a few times. You can also see the drill down here, and I'll talk about the drill more now. So when I took this piece out, I was really confused what was going on, but after I tinkered with it, and since I left this battery, I could still spin it with and see what was going on. I was able to find out that this piece right here, which you might be wondering why it's taped on, it's taped on because from here forward, it's just a gearing down mechanism to make the drill spin slower, because this motor spins real fast, and it would not be able to work with a drill. Anyway, that it doesn't connect mechanically in any way because there's not really a way to do that, so I just taped it on so I could not lose any of these gears, because they do just slide out the back. So I figured out how this worked, just kind of testing it, and how it does work is there are 1, 2, 3, 4, 5, 6, 7 gears, I guess, really, and there are 3 of them that are exactly like this on the other side, except they don't have a hole in the middle. And what happens is there's a small gear in the middle like this connected to the motor, and it spins the 3 gears on the outside, which spin this big ring around them on the outside. And then that ring spins on this side, which spins these 3 gears around this one. And these 3 gears have holes in the middle, and those holes allow the 3 prongs that is on here. You can't see the 3 prongs in any of these pictures, but there are three prongs you can see from the holes that stick in here and allow this to be spun and spin the top of the motor. As it needs grease, of course, to keep it lubricated, and as it's spun, the trigger has a little bit of speed manipulation, as most drills do, not a whole lot. But the reason this is needed, like I said before, is because when the drill is fully pressed all the way down, the gear spins much, much faster than you would want to screw in a screw or other piece you might need for a drill bit. So what this does is, I'm not sure the ratio, but it gears it so it's spinning slower, and that allows the whole drill to function properly. I'll talk about what else I was planning to use from this. So my original plan for the RC car was to use the batteries from these drills, and the batteries were originally, I didn't think they were going to be like this. I thought they were going to be big batteries like on the drill I have at home, which is just a large battery pack, not individual AA looking batteries. These aren't double A's, but they just look like it, which is why I said that. Anyway, when they came on the drills, they were in parallel, yes. And that, I'm not sure exactly what it did. I think they were in parallel to allow a longer battery life, as opposed to in series, which would allow there to be more power draw. Like it draws more at a time. Anyway, so what I needed was batteries in series, because that would allow more power to go to all the places at the same time, as opposed to less power. So these are 3.7 volt batteries, and I needed at least, I think it was 8 volts to run just the Arduino. And the mistake I made was trying to run everything from the same power source, I think, and so there wasn't enough power for the Arduino and the motors and all the other modules that the Arduino needed. Anyway, so when I put these into series, they were generating about 8.4 volts, or should have been. It was kind of scary when I bumped the wires a couple times. They sparked and freaked me out a little bit. Anyway, I cut these wires off, and there was a plate right here, I believe, that was soldered to these batteries because it needed to connect to both the positive and the negative at once. And down here there was just one wire connected to the negative right here, and then a positive connected right here. Because if you would have connected it, there would have been what's the word? Shortage. That's what I'm looking for. And it would have been sparking all over, which I learned the hard way by connecting both positive and negative both ends, because I wasn't really sure what I'm learning. So part of the thing I learned was, don't connect positive and negative of high voltage battery together, because you will not have a good time. The last thing I learned about this drill is that this plastic piece right here, that's what changes the direction in a reversible drill, like a drill that you can have go forward and backwards. And I always wondered what makes the trigger from, or what keeps the trigger from being pulled while it's in the middle, and what would happen if it was in the middle. And so what I figured out was, when this goes into the middle, there's a plastic piece on the trigger that gets stopped from moving, and if you move it to either side, it's not in the way, so the trigger can get pulled back. And when this is on one side or the other, something in this black box changes electrically and allows the drill to spin in the reverse direction. I was unable to figure out exactly what that was or how it worked, but that is my hypothesis, and I believe it to be true. So yeah, that's pretty much all I learned from this project. I say all I learned, but it's actually a lot more than I thought it was going to be, especially for how ambitious the original project was. and how little I actually achieved in the original, I still learned a lot from just this small part of the project, which, now that I think about it, was a very large project. So, yeah, the whole drill came apart relatively smoothly. A few bumps, especially when I spilled the ball bearings and had to pick them up. That was kind of annoying. Other than that, I think I got the whole thing apart without any major breaks. I think there was one plastic clip casualty in the process, but I don't think I'd need it in the future. I don't plan on putting these drills back together. Anyway, that's my project. I did learn a lot. Hopefully I can do more with these motors in the future because of this currently they are unused. Yeah.